Hello everyone! In this virtual lab, we're going to see more complex circuits. Here in the circuit, there are two parallel branches, each with two resistors in series. What do the currents tell you about the resistors in the two branches? Well, since the current in the left branch is smaller than the current in the right branch, therefore, the resistance in the left-hand branch is higher than that in the right-hand branch. According to Ohm's law, which states that resistance equals to the potential difference divided by the current, this means that there's an inverse relationship between the current and the resistance. As the current decreases, the resistance increases, and vice versa. What do the potential difference across the resistors tell you about their values? In each branch, the resistor near the top has a higher value, and the ratio of the resistor values is the same in both branches. The ratio of the resistor values is about 10. How can you calculate the total resistance in each branch? You are correct by dividing the potential difference by the current in each branch. Now use the parallel and series resistor equations to work out the total resistance of the circuit as well as the current you would expect to get and check against the readings on ammeter 1. So let's go by steps. First, the resistance of component 3 is equal to the potential difference divided by the current passing in this branch, which is equals to 0.455 ammeter. So the resistance here is equals to approximately 10 ohms. The resistance of component 4 is equals to 0.455 divided by 0.455, which gives the resistance of 1 ohms. And here component 3 and 4 are in series, so their total resistance is equals to their summation equals to 11 ohms. Now, let's move to the left-handed side branch and start with component 2. Component 2 has a resistance of 4.545 divided by the current, which is 0.045 ammeter, equals to 101 ohms. Component 1 has a resistance of 0.455 volts divided by 0.045 amperes equals to 10.1 ohms. Their total resistance equals to approximately 101 ohms. Since they are in series, the total resistance is additive, and now we have a reduced circuit. Here's a total resistance, and here's another total resistance. These two total resistances are in parallel. To find our total, we use the equation of the total resistance in parallel, which states that I over R total equals to 1 over R1 plus 1 over R2. So the total resistance can be calculated, and it's equals to 10 ohms. Now, if we have a power supply of 5 volt, we can calculate the current using Ohm's law. The current equals to the potential difference divided by the total resistance. So, it's equals to 5 volt divided by 10 ohms equals to 0.5 amperes. And this is equivalent to the value of ammeter 1.